address calculation. Let us for a while talk about address calculation. If I just say A of, say A of, I am saying 0, 2. A of 0, 2 means I am referring to the 0th row and 3rd column. Column index is 2 means I am referring to 3rd column. This means that first go to the 0th row. That means nothing but the address 200. Then how much to jump? I have to add some address. You already reached to the row. Then the job is to only jump by so many number of columns. Index 2 for the column indicates skip 2 elements. One rule of thumb is, whatever is the row index, skip those many rows. Whatever is the column index, skip those many columns. So this tells me to skip 0 number of rows. Means start from the base address, that's it. Don't skip any rows. This 2 tells me that skip 2 number of columns, 2 number of elements or 2 number of elements in that particular way. So to skip 2 number of elements, I have to multiply this 2 by size of int, size of integer, which is nothing but, by the way, 2 over here. So from 200, I have to jump 2 multiplied by 2, that is 4. So my address calculator comes out to be 204. So A of 02 will start at 204. So given a particular row, we skip the number of columns. This address calculation, once you reach in a row, how to reach to that column, this address calculation is exactly the same as address calculation for one-dimensional array. Address calculation of one-dimensional array. Now let's slightly complicate it out. My address calculation was not for A02, but it was rather for A22. It was, say, A22. Meaning, skipping these 2 number of elements in the current row and multiplying by size of int, that is 2 multiplied by 2, that is 204. That is adding 4. Adding 4 was a good idea. That is still correct. This is still correct. Adding into 200, which is base address, is also still correct. But how do I skip additionally these 2 number of rows? I need to skip 2 number of rows. Meaning for each row, since my each row can contain 5 number of elements, I have to multiply it by 5. Skipping 2 rows means skip 5 plus again skip 5. Had this index been 3, then again skip 5. Had it been 4, again skip 4. Because initially it was 0, we skip nothing. But since it is now 2, skipping 2 rows means skipping 2 multiplied by 5, that is 10 number of elements. And for each element, size of int, that is 2 number of bytes, I need to skip. This is same as size of int. Why am I purposely writing down this macro size of int over here? Because if it is character, it will be 1. If it is float, it will be 4. If it is double, it will be 8. That value will change. So my overall address calculation for A22 will be 200 to start from here, that is the base address, plus 2 multiplied by 5, that is 10, multiplied by 2, that is 20. So it will be 200 plus 20, which will take me just at the beginning of this. And then skipping 2 more number of elements will bring me here. That will be my final destination when I am saying A22. To reach here, I need to skip 2 number of elements, which is already done. 2 multiplied by 2, that is 4. So 200 base address plus this 20 plus 4, which will be the value 224. Let's check whether it is correct. Yes, this number will be starting from 224 to 226. Thus, A base address, simply when you mention 200 is taken up. Row index, when you mention, those many rows are skipped, that is 20. Column index, when you mention, those many number of elements are skipped, so you reach to the column. First you reach to the base address, then you reach to the row, then you reach to the column. That is also why it is called as row measure form memory layout. This is the way memory address calculation takes place in two-dimensional arrays. This is the way memory address calculation takes place in two-dimensional arrays. Now suppose I want to, there is one more shade that we are yet to talk on this. We talked about declaration, we talked about definition, we talked about memory layout, we talked about syntax of the two-dimensional array, and we also covered about how do you use printf for printing one element, how do you use scanf for scanning one element. Two more small topics we will finish out in this. One is initialization of a two-dimensional array, and also how to deal with an array using loop. How to deal with array elements using a loop. Let's do that also. When I am saying A, I, Z, if I happen to say A, I, and Z, I can do this in a printf if I am printing the array. I can do this in a scanf if I am taking input into the array. Or I can assign it to some number, say 9, if I am storing 9 everywhere. Or I can assign it to some calculation like S equal to S plus. Some number I am taking here and using it in calculation. In what logic do you want to use these elements is another issue. Either for taking input or giving output or using it in some calculation to generate some value. That is your lookout. But when you reach out to this A of Ij, what are these I and Z? How do you vary them? Suppose you want to keep I constant and keep on varying Z. Meaning, for one row, deal with all columns. Then for another row, deal with all columns. Then another row, deal with another column. Just remember one thing. What is changing fast is column. Because it is a short jump. What is changing slow, it is the row, which is a faster, which is a longer jump. So, inner for loop should represent for Z equal to 0, Z less than something, and Z plus plus. This will mean that inner for loop is taking care of all the columns for a given row. I will remain the same everywhere and Z will go on changing. So if I say now outer for loop is suppose for I less than something, I plus plus, like this. So if I is 0, for that all column values are considered. Then entire for loop one iteration is over. Next time when I increment I, it will go to the next row. This is what is row measure also. Deal with one row first, then deal with the second row. That way I am addressing this in a sequential manner. In the way the memory is given, I am kind of accessing if I am writing down like this. Thus we understand that I here takes care of rows. Number of rows, how many? Number of columns, how many? They can be different. As here there are 3 maximum rows and 5 maximum columns, I will say here I less than 3, Z less than 5. I will never be actually 3, it will always be less, that is maximum 2. Z will never be actually 5, that will be always 1 less, that is maximum 4. So in this manner, inside the core of the loop, if I am saying A of Ij, my access will continue like this element, this element, this element, this element, this element. The moment I do this, inside for loop is over. Then I go in the outer for loop and take care, I becomes 1. Then again this entire for loop happens like this. That way the story goes on. That way the story goes on. For example, let us do a trick just for the sake of understanding. If I say A of Ij equal to, suppose I. If I say equal to I, what will this loop do? When I is 0, entire inner for loop will store here 0, 0, 0, 0, 0, like that. Then it goes for I equal to 1, then it will store here like 1, 1, 1, 1, 1, like that. Here it will store like 2, 2, 2, 2, 2, like that. I hope I had purposely created this example so that you understand the significance of when is Z changing and when is I changing. I is row index and Z is column index. Now suppose if I make it like I multiplied by Z. Just for the sake of understanding, I am doing this. I multiplied by j. Then this value will be 0 because row is 0, column is 0. What we store in the element is what we are writing here. And which element do I access is what I am writing here. This is row index, this is column index. They together tell me where to write. But this tells me what to write. Many students get confused between when the number is used inside parenthesis and when it is used outside the parenthesis. Outside the parenthesis is what is actually written over there. This is actual value. And inside parenthesis is just telling us the place where to write it down. So place to write is 0th row, 0th column, multiplication of that is 0, so 0 gets stored here. That way again it is remaining 0, this becomes 1, 2, 3, 4, anything. 0 gets multiplied with so many, but everywhere obviously 0, 0, 0, 0 will come. Because 0 is getting multiplied. But next time when I becomes 1, I will do 1 multiplied by 0 will be 0 here, but 1 multiplied by 1 will be 1. 1 multiplied by 2 will be 2, 1 multiplied by 3, 1 multiplied by 4, like that the multiplication will come. This example is just to indicate that significance of index is different, and when you use I and j inside for some other calculation, that significance is different. Obviously, I can probably not do this, and if I say printf %d and put all this inside that will just print my array into a row measure form. Of course, I had not put \n, so it will come in one single line. After this, these values will come like that. But if I use it like this, if I put a \n over here, what it means is once one row finishing, and inner for loop is all about one row. So once one row dealing is finished, I can go to the next line. So it will appear like this now. One row over, next row, that way the story will go on. This is the way we can use it for printf. In the same manner, I could use it for scanf. The difference will be like, in case of scanf, instead of printf I will use scanf, I will say %d. Only one small change is you don't forget to give that ampersand. And if I do that, whenever this is getting executed, this will pause 15 number of times. For every element, it will wait when the keyboard is yet to type. You type, it will take the value. You type, it will take the value. Or you just type 15 number of values and then hit enter, then all these values will be taken as input. The array will be filled in. This is, by the way, another way to define the array by taking the values from keyboard. Why am I calling it definition? Because declaration is already done. An empty memory location block is given to you, and then you may write down this code. This code can be written immediately, or you can write it after 200 number of statements. That's why there is a gap between memory being given and memory being filled. That's why this is called as definition of the two-dimensional array. That's why it is called as definition of the two-dimensional array. I hope this is clear to you. This was about using loops to access the array. And what I showed you was accessing the array for one row, all columns, another row, another column. Now, if I simply access A of ij, but do it other way round, like j equal to 0, and this will be I. This is j, this is j, and this is I, meaning outer for loop is for j, and inner for loop is for I, meaning that for a given column I want to deal with all the rows. For a given column I want to deal with all the rows. So I should be then varying from 0, 1, 2 max, not 5. It can be 3. And this can be now 5. In this case, what I will be doing is, I will do for j0, I0, meaning this. But then j0, I1 will be the next operation. I will first finish, and then I will go this. That way, I won't be accessing the array in a horizontal manner. This will be also okay, but this will deal with the array in a vertical manner kind of a thing. That is, for one column, you deal with all the rows. Another column, you deal with all the rows. So this will access 200 location first, then 210, then 220, then 202, then 212, then again 222. This will be, by the way, not in line with the way the memory is provided. So normally people don't do this.
Because the memory provision is row wise, you access also row wise. The older method, outside I is normally for row, outside for loop and outside index is normally for row, and inner for loop and inner index is normally for column. Hope that's clear to you. Now, the last point that I want to mention on top of here is the initialization of the array. What do you mean by initialization of the array? Initialization means when the array is getting declared, that time itself you write something, some value in that. Means I am just writing the array. I am declaring the array size is say 3 by 5, 3 rows, 5 columns. And I will not put a semicolon and later on think of filling the values. I will directly say equal to and I want to fill the values. How many values? How many rows? 3 rows. So let's put 3 curly braces first. So this curly braces blocks takes care of 3 rows. In every row, how many column values? 5 column values. So go on giving these values here. First row has values 0, 0, 0, 0, 0. So I am done with first row. Then put a comma. Second row has values 0, 1, 2, 13, 4. 0, 1, 2, 13, 4. These are the values which are seen over here. Then the last, suppose I don't want to give any values. You can't skip like that. You just at least have to give empty commas. Then there is a value 21 and keep a comma and don't write anything. If I simply write down 21 here, this 21 will come here. That's also one point gets understood from this unfilled array kind of an example. So once you give first row, second row, third row, your row number of rows are over. Give the last ending curly brace and semicolon. Here also give one more curly brace. This means that two-dimensional array is initialized like this, meaning not only memory is given by this declaration, but the entire values are also filled up in the array before you start doing any calculation. This stuff is different than declaration and different than definition, because this is declaration plus definition. Not only array is provided, but values are also filled in that particular array. Now there is no problem if you don't give this curly brace, these. If you go on giving the values flat like this in a comma separated manner, then also it will be stored like this, because we already studied the memory is anyway contiguous for a two-dimensional array also. So in today's lecture, in short, we have covered about what is a two-dimensional array, what do we mean by the two-dimensional growth or linear growth in 2 dimensions, how is it different than one-dimensional array. Try to give answers to your questions, to these questions, once you go through this particular lecture. How is 2D array different than 1D array? What do you mean by 2 dimensions? How is it declared? How to initialize it? How to define it by one? How to read access a element by putting it on left side of equal to, or putting it on the left side, you do a right access of that element. When you put it on the right side of equal to, you perform a read access on that. What is row major form? How is address calculated? What is the significance of row index, column index? How do you use it in printf and scanf? When you use a double for loop, inside for loop will represent column changing and outside for loop will represent the row changing. These are the, and of course with actual memory address calculation, jumping from the base address, how is it done when you just mention a of ij. These are the topics that we covered throughout in this today's topic of two-dimensional array. Thank you.